For nearly 700 years, one of the deadliest events in human history had no confirmed starting point. The Black Death killed somewhere between a third and half of Europe's population between 1347 and 1351. And historians had theories about where it came from: China, Central Asia, the Mongol steppe, but no hard physical proof tracing the pandemic back to a specific place and time. Then, in 2022, a team of geneticists published a paper that did something historians had wanted for centuries. They found patient zero's neighborhood using DNA extracted from teeth pulled out of a cemetery in the mountains of modern Kyrgyzstan, and a wild rodent that most people have never heard of. The animal is a marmot. And the story of how researchers traced humanity's most catastrophic pandemic back to a specific mountain valley, using genetics that didn't exist as a scientific tool until decades after historians started asking the question, is one of the more satisfying detective stories in modern archaeology. If real scientific breakthroughs solving centuries-old mysteries are why you're here, subscribe and turn on notifications. We go looking for the next one every week. The search for the Black Death's origin actually starts with a strange archaeological clue that had been sitting in plain sight since the 1880s, largely ignored. In the late 19th century, a Russian archaeologist excavated two cemeteries near Lake Issyk-Kul, in what is now Kyrgyzstan, close to a site called Kara-djigach in the Tian Shan mountain range. The gravestones, inscribed in Syriac, a language used by Nestorian Christian communities that had spread along Central Asian trade routes, recorded an unusual spike in burials during the years 1338 and 1339. A full 8 years before the Black Death is documented as reaching Europe. Several of the inscriptions specifically mention death from what was translated as pestilence. For over a century, this remained an interesting historical curiosity, noted by a handful of specialist historians, but never confirmed as connected to the later pandemic, because there was no way, using the tools available at the time, to actually test whether the disease behind those 1338 deaths was the same pathogen that would devastate Europe less than a decade later. That changed with the development of ancient DNA analysis, a field that has transformed historical epidemiology over the past 2 decades by making it possible to extract and sequence genetic material, including bacterial and viral DNA, from remains that are hundreds or even thousands of years old. In 2022, a research team led by geneticist Maria Spyrou, working with historian Philip Slavin and a broader international group of collaborators, obtained permission to test dental material from individuals buried at the Kara-djigach cemetery, specifically from those 1338 and 1339 burial spike years. Teeth are particularly valuable for this kind of analysis because the dental pulp, protected inside a hard enamel casing, can preserve fragments of pathogen DNA that circulated in a person's bloodstream at the time of death, long after softer tissue has completely decomposed. The results, published in the journal Nature, were unambiguous. Researchers successfully recovered and sequenced ancient DNA from Yersinia pestis, the bacterium responsible for plague, in remains from the 1338 to 1339 burial cluster. This alone confirmed the local oral and inscriptional tradition had been accurate. Whatever pestilence killed these Central Asian trading community members really was plague. But the more significant finding came from comparing this ancient genetic sample against the broader Yersinia pestis family tree, which researchers have been carefully reconstructing for years using both ancient and modern plague samples from across the world. The kara-djigach strain turned out to sit remarkably close to what geneticists call the polytomy, the specific branching point in the bacterium's evolutionary tree where all 4 major lineages of plague that would eventually spread across Europe, the Middle East, and Asia diverged from a single common ancestor strain. In practical terms, this meant the 1,338 kara-djigach sample wasn't just related to the later Black Death pandemic strain. It appeared to be extremely close to the ancestral source strain itself, the genetic point of origin from which the branches that caused the Black Death and several subsequent plague pandemics all descended. This was as close as ancient DNA analysis can currently get. A genuine X marks the spot for where the pandemic's ancestral lineage was circulating shortly before it began its documented spread toward Europe. This is where the marmots come in, and it's a detail that connects genuinely fascinating modern wildlife biology to medieval history. Yersinia pestis is not, and never has been, primarily a human disease. Humans are what epidemiologists call an accidental host. The bacterium's natural reservoir exists in wild rodent populations, and the Tian Shan mountain region where kara-djigach sits happens to be, to this day, home to large wild populations of marmots that carry sylvatic or wildlife cycle plague naturally, maintained in the wild rodent population, largely independent of human activity, transmitted between marmots and the fleas that live on them. Modern epidemiological surveys conducted in this exact region have repeatedly identified active plague circulation in local marmot populations, meaning researchers aren't reconstructing an ancient ecological relationship purely from historical inference. They're describing a disease cycle that demonstrably still exists in the same mountains today. The most likely transmission chain researchers now propose connects local human communities to this marmot reservoir through several plausible, well-documented historical pathways. Marmots were, and still are in parts of Central Asia, hunted for their fur and meat, creating direct opportunities for flea-borne transmission during hunting, skinning, or food preparation, while fleas that had fed on infected marmots could also transfer to the black rats that historically traveled alongside human trade caravans, creating a bridge from the wild sylvatic cycle into a human-adjacent rodent population capable of carrying the disease along established trade routes. And kara-djigach was not an isolated backwater. It sat directly along a branch of the Silk Road trade network, the sprawling overland trade system connecting China, Central Asia, the Middle East, and Europe, which meant a disease that established itself in trade communities here had a ready-made transportation network toward the Black Sea, and from there, the Mediterranean world. Historical records independently document that by the mid-1340s, plague was spreading through Central Asia and into the Golden Horde territories along the Black Sea's northern coast, reaching the Genoese trading colony of Caffa in modern Crimea by 1346. From Caffa, according to a well-documented contemporary account written by the Italian notary Gabriele de Mussis, Genoese merchant ships fleeing the besieged, plague-stricken port carried the disease directly into Mediterranean Europe in 1347, landing first in Sicily before spreading rapidly across the continent over the following 4 years. This gives researchers a genuinely coherent, evidence-supported chain spanning nearly a decade. A wildlife reservoir in marmots circulating naturally in the Tian Shan mountains, a documented spillover into a local trading community in 1338, genetic confirmation that this local outbreak sits at or extremely near the ancestral root of the pandemic lineage, a plausible transmission pathway along existing Silk Road trade networks, and a well-documented arrival in Crimea by the mid-1340s before the final jump into Mediterranean Europe in 1347. It's worth noting that this doesn't claim kara-djigach was necessarily the single, absolute point of origin for the entire pandemic. The 2022 study's authors were appropriately careful to describe the site as sitting extremely close to the ancestral branching point, which is the strongest evidence currently available, rather than claiming absolute certainty about the exact first human case anywhere on Earth. What makes this discovery genuinely remarkable isn't just that it solved a 700-year historical question, it's the method. 19th century archaeologists dug up gravestones mentioning pestilence and had no way to confirm what that word actually meant medically. 20th century historians developed sophisticated theories about the Black Death's Central Asian origins based on trade route logic and documentary fragments, but lacked any way to test those theories against physical evidence. It took 21st century genetic sequencing technology, applied to dental pulp extracted from 7-century-old teeth, to finally connect a wild mountain rodent, a forgotten trading community, and the deadliest pandemic in recorded human history into a single, evidence-based chain, proving that sometimes the most important historical breakthroughs aren't found in a newly discovered document, but in bacteria that had been quietly waiting inside a tooth for 700 years for the technology to finally exist that could read it.